వినిపిస్తున్నది కదా, విజిబుల్ అవుతున్నది కదా, ఓకే ఫైన్, విల్ స్టార్ట్. Okay, we'll start. So till now we have completed up to graphs, right? So this is the last slide we have seen, the special cases. So next we'll start with the questions regarding graph, and then we'll start off the motion in a plane. So what is the average acceleration for each graph segment in figure? Describe the motion of the object over the total time interval. Also calculate the displacement. So if they are asking to calculate the displacement, what I should do? The thing I said, I should take the area of that. Area means I should multiply both x and y axis, right? No? Okay. So area. So first area of this triangle, and then area of this square or rectangle, and then second area of, third area of this triangle. So what is the area of the first diagram? Half into base into height. So half into base is 4 minus 0 is 4, and the height is 8. So 1 times, and this is 2 times. Yeah. So it is 16. And the second one, it is how much? It is 4, 6, 8, 10, no? So 10 minus 4 is 6, and height is again 8. 8 6 are 48. And the last one is, it is 14, 16, 18. 18 minus 8 is 10. So half into 10 into how much height is? 8. Okay. So answer is 40. So 16 plus 48 is 54, 64, and then 40. 104 is the displacement. Okay. So what is the average acceleration they are asking? So average acceleration in the sense, what is the meaning of acceleration? Velocity by time, right? So the change in velocity with respect to change in time I should take, no? So here the change in velocity for the from O to A. So average acceleration from OA should be equals to, what is the acceleration at OA? VA minus VO by TA minus TO. So which is nothing but acceleration at A is 8 and O is 0. So 8 minus 0 by, what is the time taken? 4 minus 0, right? So 4 minus 0, which is nothing but 2 meter per second square, right? No? And if you see here, if I take the angle, it is less than 90, no? It is positive acceleration, right? Yes or no? And if you see in this case, it's a constant acceleration. So VB minus VA, same, no? So acceleration will be 0. So in this case it is 0, it is 2, and in this case what will be the acceleration? First we will find VBC. So VC minus VB, right? Yes, no? By TC minus TB. So which is nothing but 0 minus 8, na? 0 minus 8 by how much it is? Time 18 minus exactly 10, no? 18 minus 10, which is equals to minus 8 by 10. So minus 4 by 5 meter per second square. So it's a deceleration, and if you see the angle, it is greater than 90, right? No? So we got the acceleration as well as the displacement also. So if you take the tan theta or slope, you will get the acceleration, right? No? And if you find the area of that, you will get the displacement for VT graph. Okay. So there is second question here. Figure here gives the velocity time graph for a body. Find the displacement and distance travelled between 0 and 7 seconds. So 0 and 7 seconds, no? So from this point to, wait, So from this point to this point I should find, right now. So if you see here, this is my origin 0, exactly, this is the horizontal line. So this is 4 and this is minus 4, right. So upper part I should consider as positive, down part I should consider as negative. So what they are asking, distance and displacement. No, so distance means total thing I should add it. So displacement means positive and negative, right now. So if you see here, this is one triangle, rectangle, triangle, again rectangle, triangle, no? Yes or no? So I should find the area of this and sum up, I will get the distance. So distance is nothing but 1 plus 2 plus 3 plus 4 diagrams, and the displacement is 1 plus 2 plus 3 minus 4. Okay, got it, no? So if you find the area of this first one, what will be the area of the first one? Half into base is 2, height is 4, plus base is this 1, 2, 3, 4, no? So 1 into 4, and here base is 1, so half into base is 1 into height is 4, right. And here if you see, plus half into base is 7 minus 4, 3 into height is 4. So this is my distance. So displacement will be equals to the same thing I am going to return minus this one. Okay, got it, no? So we will see remaining questions and we will start with the motion in a plane now. Okay. So the next topic is motion in a plane. Write down. So till now we have seen the one dimensional. So plane is nothing but two dimensional, no? So it should be in both x axis as well as y axis. Okay. So for example for plane, projectile or circular motion, etc. Okay. So these are the examples of plane. Projectile in the sense I am projecting a particle, so it should be in both x and y axis. Circular motion also both x and y axis or any two axis will take. Okay. Yeah, position and displacement vector. So we have seen a position or displacement vector either in one axis. So one axis in the sense either it can be x, y or z. So x is nothing but I cap, y is nothing but j cap, k is nothing but z. So I mean I is nothing but x axis, j is nothing but y axis, k is nothing but z axis. Okay. Here the position vector r of a particle p located in a plane with a reference to the origin of xy reference frame is given by xi cap plus yj cap. Okay. And where x and y are the component of r along x axis and y axis. Okay. So let the particle move through the curve from point p at a time t and p dash at time t dash. Okay. So initially this is my point. Okay. Now the point has been moved. Okay. This is the initial yes. So this is my initial position. Okay. Now if I consider the initial position and the final position, that is p dash. Okay. Final position. So what happens here, some displacement has been taken place, right? No, so displacement is nothing but change in position, yes, no. So change in position in the sense, like if you take, yeah, P as xi plus yj and P dash as x dash I plus y dash j. Okay, so change in position is nothing but this is P dash minus P, or change in displacement will say. Okay, taken. Done. Done. Completed. We'll go for the next. Okay. So next is velocity. So whatever we have seen there in straight line, like position, displacement, velocity, acceleration, the same thing we are going to see but in two dimensional. Okay. So the average velocity of a particle is the ratio of the displacement to the corresponding time interval, right? No, like velocity is nothing but displacement with respect to time, right? So here V average is change in displacement by change in time. So we have seen that change in displacement in previous case, no, I mean previous slide. So xi plus delta xi plus delta yj by delta t. So delta t is nothing but t dash minus t. Here delta x is nothing but x dash minus x and delta y is nothing but y dash minus y. Okay. So the same thing, like they have separated here and they have written like velocity in x axis and velocity in y axis. Fine. So this is x in I cap, y in j cap. So the direction of V average is the same that of delta r, like whatever the position is there, no, in the same direction only the velocity will be acting. The instantaneous velocity is given by limiting value of the average velocity as the time interval approaches 0. Okay. So what we have done for the instantaneous velocity in straight line, we have taken the equation and we have differentiated. The same thing we are doing here. Okay. The meaning of limiting value is explained in motion in a straight line. Yes, we have seen in straight line, no, the same thing, right? You can copy down this one. So if a graph is given, if I want to find what is the direction of the velocity, take a tangent of that point. Okay, the tangent will give the direction of the velocity. Okay, so if a circular motion is taking place, so okay, this is the direction, anti-clockwise direction. If I take a point over, then if I draw the tangent, no, that will be my direction of the velocity. I'll draw here. Suppose this is my circular motion. If I take a point in this case, if I draw a tangent, no, this is my direction of the velocity. If I take a point here and if I draw the tangent here, this is my direction of the velocity. Okay. Done. If you have done, we will go for the next one. Done. So limiting value means like here we are going to take a differentiation, like limit tends to 0, we'll say, no, like in mathematics we have learned limit tends to 0, the same thing. Done. So velocity in components form, the same thing we have seen, no, like velocity in component form in the sense in x axis and y axis. If they are asking for the magnitude of that velocity, no, we are going to take the under root of vx square plus vy square and we will find the v, like magnitude of that velocity. Okay. Similarly what we have done in the straight line also. Okay, the same thing we are going to follow here. And if I want to find what is the angle between them is y by x, tan theta we have found, no, yes, no, so y by x, so vy by vx, so theta will be is the tan inverse of vy by vx. You can note this, from this you can note it down. If you have done, we'll go for the next one. Yeah. So acceleration, the average acceleration A of a particle is the ratio of the velocity to the corresponding time interval. So delta V by delta T. So V is nothing but Vx I cap plus Vy j cap, and delta T is nothing but like T dash minus T, like final time minus initial time. Okay. So here also acceleration have been taken in terms of x axis and y axis. So the magnitude of acceleration will be under root of ax square plus ay square will take. Okay. So instantaneous acceleration means at that point we will find that instantaneous. So what we are going to do? The differentiation method only. Okay. So dv by dt. Okay, you can take down. So this is the main important point. So in straight line, no, for velocity and acceleration will be in the same direction or opposite direction, but it will be in the straight line. Okay. But in plane or a space, if we consider the velocity and acceleration, the angle they form, okay, they won't be in a straight line. They may start from 0 to 180 degree. Okay. So here is the point. In one dimension, the velocity and the acceleration of an object are always along the same straight line, either in the same direction or in the opposite direction. Okay. But for a motion in a 2 or 3 dimension, they may have any angle between 0 to 180 degree between them. Okay. This is the main important point. Note that point. Here for 2 dimensional. Done. So acceleration in the component form, which we have seen in the previous slide, like acceleration will be given in x axis and y axis. When they are asking for the magnitude, it should be under root of ax square plus ay square. Okay. The angle for that will be tan theta equals to ay by ax. So theta will be in tan inverse of ay by ax. Okay. So motion in a plane with a constant acceleration. So we have seen that kinematic equation, no, the same kinematic equations we are going to use here. Okay. So we know that the change in velocity v minus, so v is equals to u plus at, no. So if you see here, v and u has been given. Okay. Should be equals to at. V is equals to, this is u, v not know initial velocity. I'll write. Yeah. So from that equation, like acceleration will be equals to change in velocity, like final velocity minus initial velocity by time taken. So v is equals to u plus at, we have seen, no. So this one what we will get, v is equals to v naught plus at. where V0 is the initial velocity, V is the final velocity, the same thing at. Okay, the same equation which we are going to use here also. Okay, V is equals to u plus at, V square minus u square equals to 2as, and S is equals to ut plus half at square. But in terms of x axis and y axis we will use. Okay. So what are the equations we will write here? V is equals to u plus at, V square minus u square equals to 2as, S is equals to ut plus half at square. Okay. Now if I take in the horizontal component and vertical component, I should consider Vy is equals to uy plus ayt, and Vy square minus uy square should be equals to 2ay sy. Okay, and sy should be equals to u plus of ayt square. Okay, in terms of, so this is for vertical, okay, this is for horizontal. Vertical in the sense y axis, horizontal x axis should come, u plus axt. Okay, similarly for the two equations, you can note that equations. I will write here remaining thing. So this is Vx square minus ux square equals to 2ax sx, and sx is equals to uxt plus of axt square. So in terms of component they have given here. Okay. Only thing you should remember, vertical y axis, horizontal x axis. Take the component separately and solve in the same equation, kinematic equations. Done. First copy down. Done. So relative velocity. Okay. So velocity we have studied. So relative velocity is nothing but like an object A is going with some velocity, object B is going with some velocity. If I want to relate with the objects, no, so object A is relative to object B, I can say, no. So object A velocity is relative to object B velocity. Okay. So wait a minute, I will explain here. You can copy down this. So relative velocity. Relative velocity. So if object A is having a velocity VA and object B is having a velocity VB. Okay. So not only for velocity, for position, acceleration or displacement, anything will have a same formula, which is nothing but, suppose if I take for a position of RA with respect, position of A with respect to B is nothing but position of A minus position of B. Okay, this is the common and general formula for relative. Okay, So if here they are asking velocity of A with respect to velocity of B, which is nothing but velocity of A minus velocity of B, whereas velocity of B with respect to A is nothing but velocity of B minus velocity of A. Okay. So whenever we are dealing with the relative velocity, we should remember first one, it is formula. Second one, the direction of the velocity or acceleration or displacement, anything. So direction is important. Okay. So direction in the sense, you can take a graph. So there it is, y axis, x axis, negative x axis, negative y axis. Okay. So the direction which is going in the right side positive, left side negative, upward positive, downward negative. Okay. For example, if I consider the same diagram and they are asking the velocities. Okay. Now in this case, VA is positive, VB is also positive. Right now, going in the same direction. Or else if I consider object A is there, going in this direction, object B is there, object B is also going in this direction only. Okay. Both are negative. Okay. Now object A is going from left to right, object B is from right to left. This is A and this is B. So velocity of A, velocity of B. So this is my positive, this is my negative. Okay. Suppose in this case they are asking velocity of A with respect to B and velocity of B with respect to A. So what I should do? This is positive, no? First, don't ever try to go for the direction. Write the formula first. Okay. So VA minus VB. VA minus VB. Now if you see VA is positive, keep positive. VB is negative. So keep negative here. Got it now? So what will be the answer? VA plus VB. Got it? Hope you understood this one. So what about VBA, velocity of B with respect to A? VB minus VA. Now see the directions. So VB is negative direction, so keep negative. VA is positive direction, keep positive. So answer will be minus VB minus VA. Got it? You can take a note of this. So this is for the position and it's a general formula. So position and it's a normal general formula for relative position or relative velocity or acceleration or displacement, anything. Okay, the same formula which we are going to use for the relative motions. So once we completed relative motion, now we will go for the graph questions which is left out, and then we will go for the projectile motion next. Okay, and we will solve questions in relative motions also. Done? So similarly for acceleration, displacement, position. So relative position, like position of A with respect to B will be equals to RA minus RB. Position of B with respect to A will be equals to RB minus RA. Then acceleration of A with respect to B will be equals to acceleration of A minus acceleration of B. Acceleration of B with respect to A will be acceleration of B minus acceleration of A. So for displacement also same, displacement of A, B is equals to SA minus SB. Okay, displacement of B with respect to A will be equals to displacement of B minus displacement of A. Okay, For this also we are going to use the same direction only. So this is my positive, negative, positive and negative. Okay. So approaching, like a simple case, approaching means I will add both of them. Going away means subtract both of them. Okay. So we will stop up to here and we will start with the boat and man problem, train and man problem, and we will solve question in the next class. Okay.